Alright, so our introduction to proofs is happening today. I kind of went through your definitions. I'll go again. A proof is just something that is a logical argument. You are trying to show that something is true or why it is true. We have several kinds. A paragraph proof, like we mentioned, we don't do many of those, but there are the kind where you would write out an explanation. We mostly focus on two column proofs, which are in the format that looks like this right here, where you have five parts. You have a given statement that will be given to you. You're trying to prove what they give you, what you are trying to prove. Geometrically, there will be a picture involved so that you can look at the picture to see. And then you put your given statement here, reasons, and you work your way through your problem, what you know and why you know it. All right. Along with our proofs today, we're going to just mainly be working algebraic proofs. So let's go back over what you glued into your journal, which is this little piece right here. This is your properties. Y'all grab a highlighter for me real quick, please. That page is white, and so it doesn't stand out. So I do want you to take your highlighter and just kind of draw around all of those statements with your highlighter to emphasize this page. Okay, so where you glued that in. These are the foundations of how you solve algebra equations. So we're going to go back over, and I'm hoping as we do that it just really makes sense as to what they mean. When you're solving an algebra expression, you are using all four of these properties: addition, subtraction, multiplication, division properties. So let me remind you of how and why you're using it. You have x plus 7 equals 15. Okay, algebraic equation. Kyle, to solve this equation, what is it I would have to do?
The addition property.
Okay, but now just looking at my numbers up here, what do I move and how?
I have no idea. I can't read it up there. It's just a plus c. It's b plus c.
Oh, no, you don't have to tell me this, just to look at my problem. I'm going to solve it. X plus 7 equals 15. How do I solve it? What do I do to move a 7 that's added to the other side?
Just minus 7.
Yes, that's all I was asking. So I'm going to move the 7 across the equal sign. I'm going to move it over by subtraction. So what's going on here is you have two equal things, and you're taking two equal things off, and then you adjust the equation to an x equals 8. But we haven't changed the value of the equal sign, and we did that through the subtraction property. We took two equal things and subtracted two equal things. That's what I was getting at, is just to solve equations, we use the subtraction property to move things quite often. Okay. So also on that same note, if you have like, there we go, 3x equals 20. Skylar, what do I do to solve an algebraic equation like this?
You divide by 3.
So I have two equal things. I'm going to divide by the same thing on both sides so that I keep it balanced, and then it changes the looks of it. X equals 20 6 2/3. But I've done that through the division property because I've divided the same thing on both sides. So everything that we do algebraically, there's usually a reason why we're doing it. It's just we've never really had to sit down and explain why we do it. We just learned to do it that way. Okay, so we even use these properties. Substitution, remember you're taking a value and putting it in for something else. So we do that whenever we have x plus 7, and then over here x is equal to 12. So we can substitute a value in for something else. You can substitute, if y equals x, I could substitute in another letter and have it y plus 7. So substitution is replacing. And then we're used to seeing that set of parentheses with a variable or a number in front. And what's the word that takes care of that, Holly?
Distribute.
Yeah, so distribution property, distributive property lets you take a number or a variable or something in front and distribute and multiply it throughout the parentheses. So all this should look familiar as far as properties go. I don't know about these three. Have you ever heard the words reflexive, symmetric, or transitive?
Mm-hmm.
Yeah. Maybe. Okay, well, let's remember what they are. So reflexive, so many people think reflection but don't think reflection. Reflexive is, it kind of seems like it's redundant. It's saying something equals itself. 8, if I have 8 of something over here, it also equals 8 of something over here. 8 equals 8, reflexive property. The main reason you would use reflexive property might be for something like this. So kind of here's a heads up. AB is a segment in both of those triangles. Okay, AB length in the left triangle and AB length in the right triangle is the same because it's the same picture. But sometimes we might need to state that segment AB is congruent to segment AB. One from the left triangle, one from the right triangle, but they are the same thing, and it's by the reflexive property. Okay. All right, next is symmetric. So what do you think, what happens to symmetric property when you're looking at it? Says A equals B, B equals A. What's that do?
It flips it.
It does. Believe it or not, you guys use this all the time. When you solve an equation and you get 8 equals X, do you usually leave your answer like that?
No.
Usually you're going to turn it around and write it that way for your solution. So it's the same thing, it's just you've changed sides of the equal sign. It's the symmetric property. So the way to remember this is if you look at it that way, it's kind of like drawing a line of symmetry, and if you flip it over the line of symmetry, they are symmetric with one another. Transitive. Look, I'm hoping this one sounds familiar from yesterday. Watch. If A equals B and B equals C, then A equals C. If the first thing equals the second thing, and the second thing equals the third thing, then the first thing equals the third thing. What is that like?
The thing we just
Syllogism.
did.
Syllogism.
Yes, it's like the law of syllogism. So it kind of transfers from wording, law of syllogism, to here's an algebraic something. All right, so those are those properties. Let's do some sample proofs, which you have on that paper sitting in front of you.
Yes.
And we'll just practice them together. Here we go. So these are your first sets of algebraic 2-column proofs, and they will eventually get glued into your notes. Maybe it's really small, but maybe highlight, please, algebraic proof notes up here at the top. Notice that it's in 2-column form. So on the left side are my statements, on the right side are my reasons. Everything here is going to have a reason for what I do. They've already solved the equations for me, so I really just have to kind of watch and see what process they use, and then I'm going to describe with which one of those properties. So it's the ones you highlighted in your box that we're going to be thinking about. Plus, you can do things like join like terms or combine like terms for solving. So looking at the first one, do you see what they did to get, oh wait, I have to stop. To get a statement even into your proof, you have to start with what is given to you. So the first statement is usually going to be what they give you, which means your first reason is almost always the given statement. You would say given. It's never any way to prove it. It's just that's your starting point. Okay. All right. From now on, all of these blanks are going to be as I go step to here, to here, to here, and to here. I'm going to give a reason for every step that I do. I'm justifying what I did mathematically. Okay, to get from this first step to the second step, that's going to be my first reason A. It's not quite lined up, but I'm going to draw arrows so you can see what we're doing. What did they do to go from here to here?
Combine like terms.
Yes, we have our x's. We've just joined them together. So that is our reason. That's one of the things that we can use is combine like terms. Okay, so you're filling in the blank there. Skylar, look with me. To go from this step to this step, what's the thing that changed?
Subtracted 12 to the other side.
Correct. So which property lets you take 12 over there?
The
Subtraction.
like of the ones we just did.
The highlighted ones we just put in terms. You told me what you did to the 12, so it's the subtraction property.
We didn't do that. So
On the highlighted paper we did.
Oh,
the one
oh,
we put in
right.
your journal.
sorry,
Okay.
I'm dumb.
So we move the 12 over by subtraction on both sides. It is the subtraction property. Okay. Can everybody see what happened to go to here? We don't normally do this step, but we have to define what they did. So what happened to go from here to here?
They remove the decimals.
Remove the decimal. So to move a decimal, what mathematically had to happen to both sides?
Multiplied by 100.
Yes, you did. I don't know why they did that step, but they did. So we're just going to follow along. That was multiplication of 100. So multiplication property. I guess they were just trying to get rid of the decimal.
Oh, that's cool.
Okay, finally, Kyle, what do you do to go from this step to this step?
You divide.
So division property.
I didn't know you could do that with the decimal.
That's just one way to
You
get it.
can.
To move on. It's kind of like a fraction. You can multiply by the denominator and make all your fractions go away.
I also didn't know you could do that, like the 3x equals 20 type thing. We did it a completely different way.
Oh, as far as division?
We never wrote it out as a fraction into a simplified fraction. We did like 16.
Either way works, I guess. Okay, well, there's your first proof. And so, I mean, it really is just as basic as that, as you go step by step, trying to figure out what property was used to get there. We're going to throw in just a little bit of geometry now. So this first one, the given statement, is actually up above. And if I were to write it in there correctly, I would write it on this side statement, KL equals 3 times PM. And on this side, the reason would be because it's given to you. But they just kind of have it written in a strange order. So they also filled in the next step for us. So they took from the picture, which is why it's geometrical, and substituted. PM value went into the PM, and the KL value went into the KL. And so they have an equation. And then they already filled out, that was the substitution property. So now we're going to go on and we're going to try to fill in the blanks as to what we did to solve. From this step to this step. And you don't have to draw the arrows, but I am right now so that you can see. It seems like I should put this next word on this line, but I put the word on the line after it's happened. So what is happening right here, Tyson?
Distributing.
Yes, this is a distribution property, but I don't put it where I see it. I put it after it's happened. So that on A is going to be distributive. Good.
Question marks in my way.
Okay, then Skylar, what happens to go from this step to this step?
You just change this like sign.
But there was a reason. Like
So
what did they move?
Oh, they just subtracted the
Yes, subtracted the 6x. And if it makes more sense for you to write it like this so that you can see that that's what happened in there, go for it. But what property then, Skylar, is that?
That's the subtraction property.
It is. And I don't mind abbreviations, but look, subtraction, substitution, those can be really close to each other. So make sure I know you mean subtract.
So could we just like put sub t?
That would be kind of the same thing as this. So I would write subtract and I would write substitute, at least. Those two. The distribution, DIST is fine. Division, DIV is fine, just as long as I know the difference between substitution and subtraction. All right, for the last one, Kyle, what's going on here? What did we do to get from here to here?
Multiplication property.
Yes, multiply by what?
-1.
Correct. So actually on that step, it could be either multiplication or division by a -1. You could do one or the other or both. Okay, good. Let's go on. Filling out the next one. Again, we have another substitution. So it's xy equals yz. They have taken the value of xy, substituted the value of yz, substituted. They wrote substitution property. Okay, Holly, to go from here to here, what happened?
They subtract the 6n.
Good. Again, if you wanted to write it in there to see that's what happened to get here, then yes, so it is the
Subtraction property.
subtraction property. Okay. Tyson, the next step,
They subtract 5.
subtracted 5. So again, it is a subtraction property. You can have the same property more than once, obviously. And then finally, Skylar.
On the last one, it's
Yes.
just the equal, the one that's equal, the reflexive.
To go from here to here, what happened?
No, you divide.
So it was the division
Oh,
property
the
that
division
got me
property.
here. Okay. So you're always looking, it seems like division should go here because that's what we're about to do, but you're always putting it on the one right after it happened. Okay? All right, now down at the bottom, let's use those same properties from that page that you highlighted and boxed in, and let's figure out to go from this step to this step, what are they doing? So if xy equals tz, and you turn that around and tz equals xy, which property? So not reflexive, not
Symmetric.
reflection,
Symmetric.
but symmetric. Yeah, it's like going across a line of symmetry that can flip. So from here to here, they flip. So it is the symmetric property. And it's so hard because we think reflection, and so that looks like that, but you just can't think reflection. Number 6. What's happening here to go from this step to this step?
Distribution.
That's it, Tyson. Good job. Distributive. Here to here. Distributive property. Kyle, what about the next one, number 7?
Plus 6 is 2. The subtraction.
Okay, but was it actually a property where it was moving across the equal sign?
No,
No, they just did what with those terms?
they just combine like terms.
Yes. So in this case, there was no movement across any equal sign. It's just combined like terms. And Skylar, what about number 8? What happens from here to here? Which one of those properties?
The transitive one.
Transitive. So transitive, if you can remember that it's like a train linking together. It's like these two are the box cars, and you literally could do angle A is congruent to angle B. Link it, and it's also congruent to angle C. So if you can link together with that same thing, then you have a transitive property. Okay, good job, guys. We'll get the assignment and work from there.
Perfect.